In this video, we'll be looking at the area and perimeter of regular polygons. Now you need to recall that a regular polygon is a polygon with congruent sides and angles. So all angles are congruent and all sides are congruent. So an example of a regular polygon would be an equilateral triangle or a square or even like a stop sign, an octagon, because all the sides are the same and all the angles are the same. So some vocab to see on a regular polygon is that first off, all angles congruent and all sides congruent, right? Okay. Now, there's a piece of it called the apothem. The apothem of a regular polygon is the perpendicular distance from the center of the polygon to a side. So it goes from the center down to the side, and it forms a 90-degree angle. Notice it does not go to the vertex. It actually goes to the midpoint of the opposite side. So it cuts this side in half right here. And finally, the radius is a other vocab we need to know for this. It's the distance from the center of the polygon to the vertex. So it still starts at the center, but instead of going to the half midpoint of the side, it goes to the vertex, to the angle. And it actually cuts the angle in half as well. So the apothem cuts the side in half at a 90-degree angle. The radius cuts the angle in half. Okay, so let's look at how this looks. Parts of a regular polygon. The radius, of course, goes from the middle to the center. So interesting note here, it makes a circle around the regular polygon. The apothem goes from the center to the opposite side at a 90-degree angle. So they actually form a right triangle if you notice. All right, so looking at the parts, what do you think this is called here? Well, it's called the radius because it goes from the center to the vertex. And this is called the apothem because it goes from the center to the opposite side at a 90-degree angle. And remember, it does cut that side in half. All right, so let's look at a regular polygon and see if we can come up with a formula. So if each side length of this regular pentagon is S, then what would the perimeter be? Well, there's 5 sides, so the perimeter would be 5 times S. Now, you notice that this has 5 triangles in it. To find the area of this triangle, it would be base, which is S, times height, which is the apothem, over 2. And we're going to do that with 5 triangles. So 5 S A over 2. So notice in the area formula, we see the perimeter, and then it's times the apothem over 2. So that leads us to our actual formula. The area formula for a regular polygon, in other words, all sides and all angles are congruent, is the area equals apothem times perimeter over 2. So apothem times perimeter divided by 2, just like we noticed back there. Of course, the perimeter is the number of sides times the length of each side. Make sure you get this formula down. All right, so let's try some problems. Find the area of the regular polygon. So A equals AP over 2. Well, A equals 6.9. P equals, let's see, there's 10. There's 5 sides. So 5 times 10 is 50. So the area equals 6.9 times 50 divided by 2. So now what you want to do is you want to plug that in, figure out what that quantity equals. So when you plug in 6.9 times 50, you get 345, divide that by 2, gives you 172.5. Now what would this piece be here? Well, it's half of the side, so 5. And could you actually go and find the radius? Sure, using the Pythagorean theorem if you had to. All right, the Australian 50-cent piece is a dodecagon. In other words, that's 12 sides. Find the area if each side is 2 millimeters. So I want you to pause and try this on your own. All right, so the formula is area equals AP over 2. Looks like the apothem is 7. And the perimeter is going to be, let's see, there's 12 sides. Each side is 2. 2 times 12 is 24. So 7 times 24 divided by 2. Plug that in, and you get 84 millimeters squared. All right, now there are some special regular polygons because of the angles that are formed. The equilateral triangle, when you draw the apothem and the radius, it creates a 30-degree angle in the bottom and 60-degree in the center because it cuts the 60-degree angle in half to make 30. The square, when you draw the apothem and radius, creates a 45, 45, 90 triangle because you're cutting the 90 in half. And the regular hexagon, when you draw the apothem and radius, creates another 30, 60, 90 triangle. But notice the difference between the triangle and the hexagon. The 60 is at the bottom, whereas the 30 is at the bottom here. An easy way I like to remember this is the 30 goes at the bottom because the triangle has three sides, 3 and 30. The 4 goes at the bottom for a square, 45, because it has 4 sides. And the 60 goes at the bottom of a hexagon because it has 6 sides. It's an easy way to remember which number goes at the bottom. So remember your rules for 30, 60, 90, 45, 45, 90. So let's try one out here. Find the area of the regular polygon. Now, I actually didn't have to label these angles, so you're going to see lots of times these angles aren't even labeled for you. You're going to have to know that a 60 goes there and a 30 goes there. So if each side is 16, we cut this side in half and we get 8. Now, that's the 30 side. How do you go from the 30 to the 60? Times root 3, so 8 root 3. And if I wanted my radius, it would be 8 times 2, which is 16. So it is an interesting note that the radius and the sides are congruent for a regular hexagon. So we plug into the formula AP over 2. We know that A equals 8 root 3. And P equals 16 times 6. So 96. So plugging in 8 root 3 times 96 over 2. So we're going to do 8 times 96. And our calculator, see what we get. So we get 768 root 3 over 2. And divide that by 2. So 384 root 3 centimeters squared. Hopefully you're able to get there. All right, I want you to pause the video and try to find the area of this regular polygon, remembering which angles go where. All right, hopefully you got there. It's a triangle, so it has 3 sides, so the 30 goes at the bottom, and the 60 goes right there. So it's a 30, 60, 90. I know my 90 is 8, so half of 8 is 4. And then to go from my 30 to my 60, it becomes 4 root 3. So, of course, that will be equal on both sides. So one side is 8 root 3. So AP over 2, so the apothem equals 4. The perimeter is, okay, one side's 8 root 3, so 8 times 3, because there's 3 sides, 24 root 3. So area equals 4 times 24 root 3 divided by 2. So 4 times 24 is 96 divided by 2 is 48 root 3 meters squared. All right, last problem we're going to look at here. What is the perimeter to the nearest centimeter of the regular octagon drawn below? So notice here, you have a right triangle. And what can we use when we have a right triangle to figure out a missing side? Pythagorean theorem. So 4 squared plus x squared equals 4.6 squared. 16 plus x squared equals, let's see, 4.6 times 4.6 gives you, sorry, my calculator messed up a little bit there. It gives you 21.16. Subtract 16 from both sides, so you get 5.16. And now we're going to take the square root of 5.16. And we get that a side length is about 2.27. Okay? So that's one side length. No, I'm sorry, that's not one side. That's half the side length. So to get the full side length, we have to double that. And we get that one side is 4.54. And it wants the perimeter. So we're going to do 8 times 4.54. So 8 times 4.54. And we get 36.32, so the nearest centimeter is G. Please make sure you do the practice problems to understand this, and thanks for watching.